Welcome to Frankensight and our YouTube channel, AskFrank15. Today, with hping, we are going to look at SYN floods, fragmented packets, UDP datagrams, and specific packet counts. Only use hping to test systems where you have been authorized to do so by the owner of the system. Firstly, hping can be used to send packets at a special rate called flood. Since a SYN flood is an important scenario to prepare for in testing, you can use hping to manufacture a small SYN flood. Please note that this is a type of denial of service attack, but not a DDoS or distributed denial of service attack unless employed by a massive number of devices simultaneously. As the frequency of DDoS attacks is constantly on the rise, I believe that people need to test for this scenario, and the hping SYN flood is a great small-scale simulation of a TCP SYN flood. Let's get started with our example. We are going to send a TCP SYN flood to frankensite-test.net, which I host locally, on port 80. So here we have hping3, frankensite-test.net, SYN, we've designated SYN flag, port 80, and a flood switch. On the right, we're capturing with T-Shark, interface, loopback, TCP, port 80. So just to note, you won't see any output here on the flood. It's too quick for there to show any output. Started, stopped it. Alright, capture has stopped. Okay, so in our capture we have a repeating pattern of SYN sent by the client, a SYN ACK back from the server, and a reset from the client. Let's look at the count. So the final count is 17,301 packets dropped. So it's quite an elevated rate. The client, again, sends a SYN. The server returns with a SYN ACK and awaits the client ACK, retaining an entry in the SYN queue memory buffer for the connection it expects to complete with the client. If the SYN queue fills up, new attempts at connecting will be dropped, creating a denial of service scenario. A common technique for mitigating this scenario on the server end is to use SYN cookies, which do not buffer memory upon receiving a new SYN packet. If an ACK is received from the client, the SYN cookie wielding server will reconstruct the SYN queue entry to complete the circuit. Now let's send fragmented TCP SYN packets to frankensite-test.net on port 80. The switch for that is in lowercase f. So I'm going to capture again on port 80, and we are going to send fragments. Notice that T-Shark tells us that we have a fragmented IP coming in, and then server sending SYN ACK back. Lastly, we're going to look at sending a specific packet count. Also, we are sending UDP datagrams instead of TCP segments, which are both informally called packets. So I'm going to capture interface loopback and UDP port 53. And I'm going to send hping3 frankensitetest.net, designate UDP port 53, and we have lowercase c 5 for a count of 5, and then verbose output.